Ahoy! Good evening and welcome everybody, this is Obi-Wan Pez for Simplex Pachinko. I am finally replacing those light bulbs. So we are going to be doing that just for a couple more minutes. I know Zach is planning on coming on over here. He is at Eat of the Two-Eye Pie. Anybody who doesn't know him, he's another one of our awesome math streamers. So we'll be, I fear that this is going to be like far too white. The lights are going to be super, super cold and white. But you know what? We're just going to have to deal with it. So I hope everybody is having a good day. We came over. I've been home for the day because our son was not feeling well this morning, but he's doing fine. Unfortunately, that means he missed picture day. Or rather, he missed the picture of the whole school that was being taken. Okay. Gotta put that. Find the socket. There we go. Righty tighty. And then put the little glass thing back on that they put up there for decoration. And then we should be good to go. And get our lights back on, because my goodness. On the plus side, if you could see behind me. Why, hello, everybody. Good evening and welcome. My name is Obi-Wan Pez. This is Simplex Pachinko. You are staring at my shorts. Apologies. Alright. Let's move all of this stuff back out of the way. And maybe not bend all this other stuff. Okay. Whew. Alright, and lights in 3, 2, 1. Woohoo! They worked. Not that I was worried that it was not going to work or anything, but the fact that all 3 of them turned on. Hey. Shorts raid. Awesome. Righto. So thank you all for coming in. My name is Obi-Wan Pez. This is Simplex Pachinko. Those of you who don't know me, I changed 3 light bulbs in that amount of time. Yeah, these are some old Lumilife halogens, I think. So they were operating, the color of them was operating at 2700 Kelvin. I don't think this actually tells me. Well, that's weird. So I discovered the G10 cap that exists here in the UK. It's just like 2 cylindrical prongs that go in and then you twist and it locks in place. Oh, there we go. 3000. Nice. So these are actually slightly warmer than the ones that they're replacing. The other ones that are older and look the same are those 2 there. However, you could see over on the left-hand side of the screen, there is a big blob of blue, which is coming from that one. I was worried that it was going to be that cold, but fortunately we got the nice warm ones. So close. So good evening, everybody. I hope you're having a lovely time. Zach, can't wait to hear about your... Oops. Can't wait to hear about your plans for next anniversary stream. Look forward to it. There's a third one somewhere. Oh yeah. Fell off the piano bench, ended up in a bucket somewhere. Okay. So, for anybody who doesn't know me, yep, like I said, Obi-Wan Pez and Simplex. I made a promise to Me Machine Rex that I would explain where exactly my name comes from, because it's been a few months since I've described it, and we'll be hopefully at some point I will get back on track and actually do like a, I don't know. You thought it was a digital blackboard mounted? Yeah. Don't I wish? How you doing, Slayer? Happy Nightmares. Welcome for the first time. What time is it? So it is now 21:40, 9:40 p.m. And because we're at 54 degrees north, I would like you to look at this. It's still actually quite bright out. And it's only gonna keep getting brighter as the season wears on. So we're gonna end up with almost like the sun. you know, the sun will still be well above the horizon at 10. No, it'll still be well above the horizon at about 8:30. It'll become twilight around 9:30, and we're still going to get this around like 10:30. It will actually not get dark, like significantly dark, pretty much at all. So I don't think we ever actually get, I don't think we ever actually get astronomical twilight in like midsummer. So it's terrible for astrophotography, but fortunately for us, Astro Canuck is not here. So we are an American family staying currently in North Yorkshire in England. I know Zach threw this all into your channel as well back on his. So we have our Math Chads, who are the wonderful streamer. I probably also need to update this. I keep saying that I need to update it. Who are currently working on some version of mathematics, whether that includes physics or programming or all sorts of other cool stuff. Harrogate is in North Yorkshire, yes. Richmond, I have not been to. So, Harrogate is a spa town, which is a bit like Bath in the south, where they have literally the baths. In Harrogate, they have the royal baths, which are where Queen Victoria used to come up and spend all of her vacation time. Well, not all, but it was one of the places they went on their way up to Scotland. We were just talking about this, one of my other friends and I, what the name of the castle was, but yeah, I don't. It's probably in here somewhere. I've got to search on it. Balmoral, yeah. So Yeah, thank you. Fetbox, you got it. Yep, so Balmoral Castle in Scotland, and so they'd stop in Harrogate on their way up and then continue on. Um, the baths are a bit of an acquired smell because they are very rich in sulfur. Uh, Saratoga Springs, yep, probably. A lot of the other well, yeah, a lot of the spa towns in America were used in 1900s, toward the beginning of the 1900s when uh, leisure, eugenics, and like changing the diet due to becoming healthy and or connecting to spiritual practices was really big. This is Kellogg, if you remember, Kellogg's, the cereal company. They used to make Kellogg's cereal. What was it? Granula was what they called it. And yes, that is where we get the term granola from. If you were to look up, there's a good video on it by... almost there. Processing. Knowing Better. So if you watch Knowing Better's video on the health movement in even stuff that connects to modern day health movement, but in the early 1900s especially, it was connected with Kellogg and a couple of other people who were really big. Oh, Graham. What's the other one? Yes, of the graham cracker. Their version was much more along the line of, we need to get these kids to stop pleasing themselves. And so therefore they went for a diet that was very regimented, and they were like, we're gonna make that happen. And yeah, no. No. you can't control. No. But yeah, they had camps where they would get especially rich people to come and yes. Thank you, Slayer. Yeah, they would get their especially rich people, rich clients, to come up to their camps and have an extended stay, do water electrolysis. Yes, I did just say that. And various other treatments that were supposed to make you more healthy. As it turned out, eating more vegetables and getting more exercise helped a lot. Some of which was attributed to actually the correct shift of diet and exercise, and a lot of it was attributed to all sorts of other stuff. Hey, Draggy. Well, especially since they're loaded with sugar these days. Come on, Slayer. Alright, so if anybody is interested in, not that, any of the differential equations type stuff that we've got over there, if you have any questions on all sorts of other mathematics, let me know. Scored 96 at your school finals, but math has always been the end game. Yeah. So, Slayer, I'm not actually teaching in schools. I'm working on a few different projects to try and pass the time, keep my skills up, acquire some new skills. I am attempting to write a bit. I'm doing a quite terrible project of, meaning that I'm terrible, not that the project is terrible. But I'm making an attempt to, write a screenplay for a book that I found, and it is awesome. If anybody is interested in science fiction, Adrian Tchaikovsky is a celebrated writer from Leeds, which is also in North Yorkshire. This particular one is called Alien Clay. I found it very much interesting. And he wrote some other books which are called, well, the series is called Children of Time. And it's about a group of humans that are trying to discover, they're trying to go to, on like a cryogenic ship, they're trying to land on a certain planet which has been prepared for them. So the idea was that they would send ahead a bunch of monkeys on the ship, the same ship they're on, mind you. They would get to the planet that they're supposed to be at. They would launch genetically enhanced monkeys and maybe chimpanzees and other large apes. Their genes had been edited to make them much smarter, and they were cohabitating the planet with a virus that would then in turn self-select and make them mate with others who were also infected with this disease, and the disease would like edit their genes while it's in them to make them better and start doing artificial selection. Yes. Hey Hamilton, how you doing? Hamiltonian. Yeah, I really liked Children of Time. I have the next 1 or 2 books, I can't remember, and I haven't read them. Fabian's your boy. Yeah. Yeah, so Alien Clay was actually my first introduction. I bought this the day we moved here, and I absolutely love it. It is supposed to be sort of a different universe, or I guess it could be, in theory, the same universe, but it's supposed to be a different universe where humans are going out and colonizing planets. They have 3 prison colonies, which you could be sent to basically start trying to, yep. Guy escape. What am I talking about? Oh my god. Phallic-shaped eggplant, yes. What else would it be, right? Why am I not coming up with the word? Not served during weddings. Touché. Terraform. Jesus. That took me long enough to get, and I didn't even find it like online. Eventually just came into my head. Okay. Anyway. So yeah, the idea is that they have sent in groups of prisoners who basically are all of the people that are the undesirables on the now fascist Earth. They're sent off in cryo ships, then they wake them up around the planet, send them down to the planet, and now they're prisoners on the planet, and also they're terraforming the planets for the rest of the humans when they eventually come out here. They're sent new prisoners every like 10 years or something like that, and it's like an entire ship worth of people, so like, you know, 100, 200, 300. And the planet that they are on is called Kiln, which is basically supposed to be reminiscent of most of its wild jungle, but everything about the wildlife that's there is completely different, and you don't have anything even remotely similar to what's on Earth. But not only that, the way that life works is completely different. And it was the first book that I really got into media literacy, before reading the whole book, and I just got it. I could see where he was going with it, and I could actually see shots from a movie, how would I stage this, how would I block this, that sort of stuff. So I was like, I've got to at least pretend to attempt writing a screenplay or something, and so I've been doing that on and off. And I've been trying to look at the Common Core standards across all states in the US and try to come up with better teaching methods for what we might be able to teach, or how we might be able to teach students. And then I'm looking to make those videos, put them on my YouTube channel, which, speaking of which, if anyone is interested, we have at Obi-Wan Pez is my gaming content channel, and at nsimplexpachinko6542 is going to be my math content channel. Hey Seth, how's it going? Obi-Wan Pez still only has 11 follows, so not many people are terribly interested in my gaming content. That's okay. But Simplex just passed 140, I believe, so we're growing pretty steadily. It's great. What else? Yep, and then I've been working on my teaching methods here, just with all you. So deciding how to teach things, in what ways we can discuss them, how might we be able to make things a little bit better, easier, more comprehensive. How about a puzzle today? Yeah, we could do that. Not jigsaw. Do you have one in mind? I imagine. Light switch puzzle. Yes. So you flip every one, and then you flip every other, and then you flip every third, and every fourth, and every fifth, until all the light switches have been flipped. So this one right up here is differential equations. We were looking at an ordinary nonlinear differential equation from, I think, last year, something like that. I grabbed my nonlinear differential equation textbook and just threw one on screen to try and do it, because we were looking at specifically how to do nonlinear differential equations. This one, actually, we didn't have to do linearization. This was just separability. So we were able to separate this thing, turn it into all x's on one side, all y's on the other, and then break that down. Oh, that's the starting point. Interesting. Okay. Okay. So I do know that that particular puzzle says that if you flip all of the pieces, or all of the switches in that order, then you end up with those, those light switches that will be remaining up will be those that have an odd number of factors. That being that we have to have repeated factors, which are those which are perfect squares. Alright, so now let's clear this. Boop. Psyche got rid of one of her emotes that I use all the time. Discuss use subs for syntax U. So... U substitution? It's like when you're doing... Come on now. If we're doing an integral, and we have, let's say, x squared both of you are the same color. Hang on. Oh, yeah. Syntax, go ahead. If we end up with something like this, so x squared e to the 2x the third dx, right? You can ask your actual question. I'll also just do one for fun here. So the way that I do this might be a little different from the way your teacher wants it or whatever, but it's fine. So what we're looking at here is assuming that we're going to take this thing and saying, okay, we want this to just be the integral of e to the u times du. That'd be super convenient if we could just make that happen, because this is a super easy way to solve this particular problem. Integral of e to the u du is just going to be e to the u plus c. So that's an interesting question. Let's try altering the one we already have. So if we make this, we could just use your example, right? So if we're using x 1 minus x, right, as our exponent, that is x. Oh, man, I only just started stream. What do you mean my battery is running low? Should have plugged in. X minus x squared. So if this is x minus x squared, then the derivative of that would be 1 minus 2x. We are allowed to make this off by a constant, but we'll just let that go for now. It's fine. So the way... you know what? Let's just make it a 3 out front. Okay. So... the way that I do this when I'm teaching my Calc 2 students is say that, okay, we want the stuff up top to end up just being u, which makes all the stuff out front, hopefully, du. If it's not, then we got to deal with some other stuff. But for right now, we'll just say, okay, is that possible? Is that a viable option? So if we let u be equal to 3x minus 6x squared, again, once you multiply it all out, that's what we end up getting. Oh, shoot. No, that's 3x. Oh, yeah, we're fine. I'm sorry. We're just... Don't worry about me. Okay, this is u. So therefore, du should be equal to 3 minus 2 times 3, the 2 comes down. It's going to be 6 times x to the first power times dx. Okay, we do not have all of those pieces out there. We are very close, but we don't have them. So what do? Okay, we need a multiplier of 3 to go out front, but then we can't just make a 3 appear from nowhere, so we have to multiply it by 1/3 to make it a power, or a form of 1. Yep. So once we get that, then we say, oh look, this is now 1/3 times e to the u du, integral of e to the u du. Again, super easy. This is going to be 1/3 e to the u and then plus c. So now the question comes, if it is a definite integral between 0 and 1. Right, then yes, we are looking for the integral of e to the u between the zeros of that particular u function up top. So x goes from 0 to 1 means that u goes from 0 to 0. And then, yeah, we've got a problem in terms of being able to come up with numbers for that. So, instead, what we'd probably want to do is say, okay, this is, sure, u goes from 0 back to 0, or, and I think the problem is the nonlinearity of u. Because it's not a one-to-one function, especially, then we're going to end up with this, well, it goes that way. We're going to end up with this parabola that goes that way, but e to the u really is looking at what happens when you have a linear function up top. So my recommendation would be to put x is going from 0 to 1, and you can't plug it back in until you return to using x's. So 1/3 e to the 3x times 1 minus x taken from 0 to 1 on x. And then here, because this is definite, we're going to end up with a minus c, so that just goes away. And so with this, we got 1/3 times the quantity. We are going to plug in... That does the same thing, doesn't it? Curses. You just wait for that moment for me to go, wait. Okay, so we need... Oh, you know what? It's the number out front, isn't it? 1 minus 2x times e to the 3x times 1 minus x. Yep. Right there. Yep. So we do actually have amounts that go up and amounts that go down centered around that point right here, 0.50, which then it's going to cause it to be an odd function with respect to that point right there. Give me a sec, because I can't have that on my channel. Yeah, so this particular function ends up working out this way. So if it were an even function with respect to that point, like if it were this thing square, I don't know how exactly we do it, but thank you, Sal. So if we were to have a function that was even with respect to that point, then it would end up working out nicer. But I think that that would also work exactly the same. Image of u has to be an interval. So it's with respect to that point, right? So let's actually, I'm going to do a function transformation on this. So we need to shift it left by 0.5. So if f of x is equal to 1 minus 2x e to the 3x times 1 minus x. This is my pre-calc specialty, by the way. F of x plus 0.5. Shift left by a half. Right, what does this make? So this is going to be equal to 1 minus 2x minus 1. Right, so this is going to be a negative 2x out front times e to the, and then we need to work this out. Very nice, yes. 3 times, this is going to be x plus 0.5 squared. Right, so now it's centered about x equals 0. Right, so now if we let this be f of x, then this next one should be f of x plus 0.5. Yep. So we center at 0, 0. We've got that point there and that point there, which you notice, right? If you negate x, you also negate y. Nice. Right, so then here this becomes 3 times the quantity x plus 0.5 raised to the second. This is f at x plus 0.5. If we were to try to take the integral of this thing, we've just done a horizontal shift, so like it didn't affect the actual integral value at all. This would, however, go from, what, negative 0.5 to 0.5? Of negative 2x e to the 3 parentheses x plus 0.5 squared dx. And then here we'd say that u is equal to 3 times the quantity x plus 0.5 squared. Du would then be 6 times the quantity x plus 0.5 raised to the first power times dx. That would be a problem. Right, because we don't actually have the derivative at the bottom anymore. Interesting. Although, in theory, right, we could just say, well, if f of x plus 0.5 were to be translated to f of negative parentheses x plus 0.5, what does that get us? So that would be a negative 2 times negative, I think, x minus 0.5. Oh, is this going to be just terrible? Probably. Oh, no. Wait, hang on. That wouldn't be here. Right, we're negating the whole input. So now it's just going to be the input that's... I don't think we can do that. Never mind. I think we'd have to go back up to here and renegotiate all of that. Huh. I guess we could just say, no, never mind. What if we just look at this as... Hang on. Let g of x be equal to f of x plus 0.5. So now we want to determine if g of x is an odd function, which we know it is, but you know, just to verify that this does in fact work the way I think it does. Here we'd say this is negative 2, negative x, e to the 3 times the quantity, negative x plus 0.5 squared. Ooh. That's not the same. Yep. All right, syntax. No worries. There's a mistake in the expansion. Thank you. Negative x. You're right. Absolutely. Yep. Right. So, because that's not squared, this is going to end up being 0.5 minus x. So instead of being squared, right, we can take that out, make this quarter minus x squared. Yeah, much better, thank you. Also, that would clean up our problem here, because this is no longer that. Yeah. Right, 3 times the quantity, 1/4 minus x squared. Now is going to make this, the derivative of that is going to be negative 6x dx, which now is a constant multiple of what's out here. So we can actually do it. And then again, we also had all this stuff. So if we clear that, this is now going to be 1/4 minus parentheses negative x squared, which is now going to be 3 1/4 minus x squared still, which is equal to negative g of x. So yeah. right? Odd centered about, well, centered about the origin point, 0, 0. So, negative 0.5 to 0.5 integral of g of x dx is going to be equal to 0. So, clears it out. Yes, because I did it wrong. Woohoo! Gotta love it. Right, the U sub does work now. This one here. So that's going to be, that's fortunate. So I think I was wrong in terms of, well, yes, I was wrong in terms of not being able to do that particular U substitution, because it doesn't matter if it's linear or nonlinear. Like the U substitution, as long as you can actually do it, is going to take care of all of that in the process. I think there is this possibility in theory that if you have something that is not one-to-one, no, because this one's not one-to-one either. Doubly not one-to-one? No, I don't know exactly. I don't think we have any issues, actually. Yeah, as long as it's differentiable, seems like it should work. Okay. Yeah, I was not understanding what you were actually talking about out there, because I was like, what do you mean syntax? Like, what? You want me to do the thing? You want me to do... You want me to explain the light bulbs for syntax? All right. Headphones might have died. They're plugged in, but, like, who knows if I messed anything up. Yeah, so switches that are up are going to be all the perfect squares. I really hope I don't have to switch to this microphone, because that would be... No. So U-sub seems like it should always work, provided you have a differentiable function and you have the derivative of that thing down there. And that includes, like, you know, all possible functions. In theory. Oh, what do we get? Nope. Okay, never mind. And just anybody who isn't aware, we are doing Game On to end Lupus for the rest of the month. I actually am not going to be here after Friday, after Saturday. We're going to head to Scotland for the week. So that's going to be like kind of our last chance, opportunity, something. I put out a bunch of rewards for individual punishments for me, and things that like we can pull for like doing a single topic. Like I'm going to do a lecture on a particular topic or something like that. So for this week, we have today is going to be problems, questions, answers, all that good stuff. Friday is going to be gaming, and then Thursday and Saturday, question mark. Don't really know. Dawn is going to be doing math tomorrow. Dawn does math. And so I'm going to not get in his way. I might do some gaming, but I might also just sit out and relax. Game with chat. I mean, that's fair. We are also... I have not done Oblivion yet, which might be overplayed for, you know, Twitch, but... I haven't done it, so... So anyway, Game On to End Lupus is an amazing, wonderful charity and all that, so we're going to be doing that for... We're going to have that link available for the rest of the month. You can hop on a VODs if I'm not in, and whatever else. If you do want to donate, if you don't, no worries, no pressure. Just, you know, there are some fun little things that I put on Tiltify to have me eat some hot peppers. Or do a math stream on a particular topic. Do a do a martial arts stream. Like, there's a bunch of stuff. So if anybody is interested, you can pop over there and take a look. We have joined up with the larger team of 8BitD, Elbel, and Coco Confession. They are people who are living with lupus, and, or at least D and Coco are living with lupus, and Ellie is waiting for her official diagnosis, but like, it's probably lupus. So their streams are also available. They mostly do gamey type stuff and community building. So good bunch of people. I like hanging out with them whenever I'm not doing stuff myself. So we're going to be hanging around, doing other stuff for the rest of the month, and then by the end we'll see where we sit. I think we have a few donations in, and thank you very much to those who did. So we have a substantial way to go before my goal of $250, but the entire team, like all campaigns put together, are 153 people, 160 people, somewhere in that neighborhood. And as a total, everybody has raised somewhere around $150,000 this year. Let's see, is it here? Yes, it's here. Boop. Get into the thing. Dashboard. 154,369.88. That's amongst all 160, like I said, some odd people. So that's pretty amazing. The total that everyone put together is trying to hit is 205,000. Um, Overall, it's not like that far of a stretch. It's also only the 21st of May. They reached over 100,000 within the first like week, so it was quite amazing. And there are some wonderful businesses, other charities, and individuals who have decided on doing match donations. So they will, for the next 2 hours, somebody is going to match all these donations, and so that is a big help to anybody doing the goals and anybody doing uh, anybody doing rewards too. So okay, ads are going to start in 1 minute. Let's look at. Do we have any others? Goodness. I don't know how to do eigenvector centrality, so we won't be doing that one. Yep. Next part of the thing. Yep. Sounds good. And if anybody else has any other questions, yeah, it's going to be like 1 minute. If anybody else has any other questions, you can drop them in Zach's chat, Zach's Discord, or Penn Center's Discord. I'll keep an eye on both of them. Those are going to be there for yes, those are going to be there for me to poke around and look into. So we'll be back in 3 minutes. Thank you very much for coming, and we'll see you in just a little bit. Infinite hotel case. Nice. I don't know how long these headphones are going to last. So anybody who hasn't been here before, my name is Obi-Wan Pez. This is Simplex Pachinko, and we do a bit of martial arts for Redeem called Good Form. So we can do kind of one of two things. I've been, prior to coming to the UK, I'd been doing no, we're still good. I've been doing Tang Soo Do Karate. Sorry, that was just a abrupt ending to that song. Tang Soo Do Karate for about 17 years, and got first degree black belt or brown belt. I was starting to work toward black belt when we decided to come to Yorkshire. I called a bunch of places and asked if they were accepting students, what kind of martial arts they did, what their belt structure was like. And only one of them like sort of appealed to me, and then they just never answered. After a certain point, I was like, that's not helpful. And then I called this guy and asked him what, if there was any room in his Eskrima class, and he was like, yes, come on over. And it's just the guy's backyard. He's got like a little in-law apartment type thing that he has usually 3 or 4 of us tucked in this little tiny thing. And then we just recently bought sparring gear. So I've got that's upstairs. I've got my helmet and gloves, and we actually smack each other in the face quite hard. Fortunately, though, it doesn't actually hurt, but it's still kind of interesting. So, as some of the redeems go, like form-wise, jeez, would awfully kind of help if I actually, you could see me. Boop. So for the redeems, oftentimes what we're doing is looking at the forms for Eskrima, which tend to have some of the basic moves in it. So number 1, the way in which you hold your Eskrima stick, also known as an Arnis stick, also known as Kali, also known as a machete. Typically going to be holding it like this so that you're pointing it essentially toward your target so that they can't see much except just the profile end. And then in order to strike out, you just kind of throw it forward, and at the same time use your backhand as counterweight. So out like this and then back. Out like this and back. Typically you're aiming basically for your own head height, which is about here for me, and you're aiming toward the opponent's eyes. So you're looking to strike them in the face and effectively blind them. This is extremely dangerous. It is extremely not okay in pretty much anywhere in the world. But if you are in a life or death situation, naturally, you're going to be using it. This also works with not just machete, but also Chinese broadsword, which I found out was kind of cool. And we used polycarbonate weapons for that stuff. So we have ones that have been molded into the proper shape. These are just standard sticks. Eskrima itself comes from a Filipino martial art, also called Eskrima, named when the Philippines were occupied by the Spanish. Number 2 is just a double strike. So that's a little boring, but there it is. Number 3 is a strike, an overhead strike, and then another strike. So this is going to go out like that, and then back. And then when we get back, we come out and over the top, strike here, and then return and strike again. It was developed by a bunch of Filipino farmers who had been working out in the fields or out in the jungle with machetes, and then were coming back home and told, "Give me your money," by a bunch of organized crime type people. So they decided to organize and say, "No, we're not going to put up with this." Number 4 switches the side you're on. So what we do is we strike out and then drop into an open stance. The left hand is typically covering around your sternum because you don't want to get stabbed in the sternum. The people from organized crime typically used little stiletto knives, and they were very quick about them. So we come out with a single strike and then duck into a open stance, and then from here the proper strike is to kick this out, and you hit your forearm with the other hand, which causes this to bounce a little bit. So it gives it a little extra oomph right at the end. And then once we do that, we bring it back over the top. And then single strike again. So single strike, drop. Really the point of all of this is to keep the tip moving, such that the person never knows quite where from all of this is going to come. Most of the strikes are probably going to come from here, so that might be what they're expecting eventually. And so giving them the gift of uncertainty is always a nice thing to do when you're in a life or death situation. And then there are motions that we can do with 2. So typically with 2 weapons, we're going to start either from a neutral position like this, where you might just be walking. Somebody else also, or our instructor also, said that guys would often carry like bales of, not hay, but like they would have material on their sticks, and they'd just be carrying like this coming home from work, and then if somebody tried to stop them, they could go like that, and they would just fall right off. So all of the stuff would just fall off and drop behind them, and then they have 2 sticks. And these would be actual sticks rather than machetes in those cases. But the motions I was doing earlier is called sticks to heaven. So this is a 45-degree angle strike, followed by a return, 45-degree angle strike up, followed by a twist and swap, another 45-degree angle strike this way, and then return, and now we're on the left. And then repeat. Let's see, we also did some other cool stuff. There is a blocking routine called a fan block, where we start from either here or back in this position. From here, it's going to come up and over my head to a backhand block, to a front hand block, and then this is going to do a comma-like motion. I don't remember what that one's called. Anyway, so from here we usually go 1 and 2, slap down, and then another standard strike that way. Let's see, when you have 2, we could probably go from here and do much the same. So we could do that. I find that a bit slow. So I might actually, from here, the other one we did was just a forehand block, which is a bit, as our Yorkshireman instructor said, was a bit cheeky. So you just come off the shoulder a little bit and then strike forward. And generally speaking, this sort of thing is going to be unexpected because they're expecting a right side strike like this. They're not expecting a left hand offhand strike, especially with me just leaning in like that. Again, being unpredictable is your best friend. So we will come in that way, followed by a swipe across the belly. And again, if this is a machete, big deal. That is now up here on the shoulder, and then this comes and does that comma strike, and then we repeat. So from here, this comes up over the top, this comes across, and then this does a comma strike. And then we can repeat from here again. All right, I think that's probably good. So, welcome to education time. Woo! Math night. Yeah, essentially. I mean, pretty much all martial arts were invented by, like, peasants trying to defend themselves against criminals, whether that be, like, criminals or whether that be invaders. Let's see. Good. All right, we're charging. I know what ninjutsu was. Delete the integration. Yeah. I pretty much never do that. Shoop. There you go. All right, what we got, Seth? Two considerations. Cool. Yeah, so, Slayer, yeah. Ninjutsu was originally developed to basically do a whole bunch of, like, sneak attacks on samurai. So, the person who's supposed to do every 9 does every 5 instead. Yep. So it's only a consideration based on normal rules. You don't have to do the whatever. Okay, so this adds a new factor to all of the 5s, which means, yeah, so they're not added to each other, which was added onto the new original rules. This is, yeah. And then on number 2, that person's the only one who did something different, or whatever the new rules are, correct? So this is going to add a new factor to every 5, which means that all multiples of 5 that are not perfect squares are now going to be on. And every multiple of 5 that is a perfect square is going to be off, except if it's also a multiple of 9. And likewise, every multiple of 9 is... Yeah, okay. So this is going to say that multiples of 5 XOR 9 will be on, except 9 will be off. Oh, I'm sorry, not 9, not 9. Wait, hang on. No, that's right, because all of the 9s will be on. You gotta give me a minute. Multiples of 5 and 9. Except 9, 81, and other perfect squares. Okay. These perfect squares are going to be off. These perfect squares are going to be on. Yeah. I must have pulled a 1 to 100. Hey. Oi. What the hell? What are you doing? So weird. No? Okay. Apparently not. I don't know. That was strange. Nope, there it goes again. My scroll bar on the right, I'm pulling up and down, and like occasionally it's just going like wobble, wobble, wobble. So that's very strange. Yeah, all right. Apparently I don't have an actual picture of that, so that's fine. To 100 grid. Yay. Hashtag not sponsored. Shh. Okay. That was dumb. Okay, so normally, right, our, come on, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So normally this would have been the case, but yeah, it's fine. So that is normally what happens. However, all of our multiples of 9, so 99, 90, 81. Oh, right. We're going at it this way. 63, 54, 25, 36, 27, 9. And then 5 is going to be, yeah, this always makes it easier, right? Because it's nice and got a nice little pattern here. So 5, 35, not 45. And then all these will be on. And all these will be on. And then not that one and not that one. Oh, right. Well, it... This is fine. It's just that one, though, because that was the only not cheated one that I missed. So, it's fine. Right, so 1, 4, 16, 49, 64. Oh, and all these other ones that are friggin' right in the middle. Jeez. It's fine. 5, 10, 15, 16, 18, 20. See, this is why you told me to do it the other way. 27, 30, 35, 40, 50, 54, 55, 60, 63, 64, 65, 70, 72, 75, 80, 85, 95, 99. That's 49 again. Yeah, okay. Oi. Right. So all of those that have a single factor of either 5 or 9 will be on. And any of those that had an even number of either 5s or 9s, or if they were a perfect square and had one of those factors, either a 5 or a 9, right, they are now going to be on. No, sorry. Perfect squares that only have one of those factors will now be off, like 36, 81. Okay, no. 81's a double factor of 9. Thank you for the follow. Femvox fan. Hey, wait a minute. No, that's true. Yeah, because we only count them. Yeah, right. I just had to be careful about the way I stated it, because as stated, 81 does not have a single factor of 9. Right, but it only gets switched once no matter what. That's okay. I've also found, Fembox, that occasionally Twitch will just, like, unfollow people randomly. So, could have been that. Could also have just been that, you know, whatever. Alright, multiples of 5 and 9, like 45 and 90, will be off, unless they themselves are perfect squares, which will happen later. 25 and 9, right? So, no, because that's just going to double up again. Right, 25 and 9. just another factor of 5. Right, 225. Jeez. Having a day. You gotta be careful where you type that, Femvox. That might ban you for posting links. Good news. Doesn't matter here. Well, I mean, within reason. Oi. Sorry, it's only 11 o'clock here. It's fine. Right, even number of switches. Yep. Think so. That we don't need that logically speaking, right? It's just 5 nor 9. Still be on. Oh, yeah, I guess. Yeah. So person 6 flipped number 15 and, sorry, flipped multiples of 15. right? So, on, that's terrible. Don't do that. On. 9, 16, 25, 36, 49, 64, 81, 100 is the normal stuff. Yeah, just different numbers. So person 6 misses 6, 12, 18, 24, but gets 30. Gets 36. 42, 48, 54, 60. Will that be off? They didn't get that, or whatever. So they're doing both. Right, and then they will get. Person who does 15 will get 45 and 15. Yeah. So that means that 90 should also be avoided, or should also be gotten there. As well as 72. No, not 72. That's not a perfect square. Or not, yeah, not a perfect square. Yep. Where did I leave off? 54, 60, 66, 72, 78, 84, 90, 96, 102. Right, so perfect squares that are evenly divisible by, no, it's the other way around. If 6 divides perfect squares, then those are going to be on. No, those are going to be off now. 15 divides perfect squares. We're going to have them on, except 90? No. 30. 30 divides perfect squares. Then those are going to be... No, that's still going to be off. Man. 30 divides perfect squares, those are going to be off. 30 divides other is going to be off. 6 divides other. It's going to be on with that exception. 15 divides other. They're also going to be on. Let's try to do it as quickly as possible, right? That's how mathematicians do it. Oh yeah, I guess. We've still got those that are on. Doesn't change anything. And 6 does not divide other. 15 does not divide other. And those are still off. Yeah, let me just run one quick check in Discord. I don't think I see anything here, so, but you know, can always just run through and double check. Hey Phobos, how's it going? Good evening, welcome back. Yeah, I'm not saying anything else in here, so if anybody does have any questions, head on over to either Zach or Penn Center's Discord and post something in there. Or you can try posting something small in chat here. And if not, we're just doing some variants of the light switch puzzle. So if anybody's heard that one, every person's given a number 1 to n, however far you want to go. Oftentimes it is considered in Hilbert's Infinite Hotel, so literally every person is given a number and all numbers are assigned. The first person will go and flip on all of the light switches down the entire hall. The second person will only change the position of every other, starting with number 2, 4, 6, etc., i.e. if it's divisible by the number you're holding, flip the switch. So whatever you're standing at, look at, again, look at your card. Does it divide the number on the light switch? If the answer is yes, flip the switch, whichever way it's going to go. And if not, move on. So we were looking at what happens when you, person number 9 accidentally does every 5 instead of every 9. What happens if person number 6 accidentally, or no, person number 15 actually, one of those two, Doesn't really matter, right? Either person number 15 accidentally does 6s, or person number 6 accidentally does 15s. Either way, they're all off. My goodness, it's a commutative property. Either way, you are changing how many times these things have been switched on or off. Yep. We also should get back to doing Euler project, or Project Euler, which is the programming challenges for mathematicians, or math challenges for programmers. Write programs so you can judge them. Oh, believe me, you would judge them. As in, what the fuck is this? You've seen some things. You were judged. Nice. Accidentally flips every third, starting from 8. Alright, interesting. I knew I should have saved a squares shaded version. I mean, we're on the last one, so what does it matter? But so again, every third starting from 8. 8, right. The number 8 does not change, but then from there, every third. So I think mostly the issue is that I can't add properly, but no, wait, hang on, different color. Right, accidentally flips. Right? This misses a lot. I mean, that's good in a way. Nope. It's one of the problems of shading from the bottom right. Well, I wasn't there yet. Right, so multiples of 8 that are not included in this, and then multiples of 8 that are included need to be switched. So at this point, nope, hang on, but not both, because that would have already accounted for it. Right, so 16 is now not going to be, and then 24 is going to be on. 32 is already switched, so it would have been switched anyway, so we're good there. 40 would have been switched, but now isn't. 48 would have been switched, but now isn't. 56 would have been switched either way. 64 now does not get its final switch. That's not final, but would not have gotten the switch from 8. 72 would not have been switched. 80 already gets switched. 88 and 96.
Can't get enough of your song of the moment? Download and indulge in the tracks you love over and over again.
So what is that? That is,
Discover an ad-free
if it follows this pattern,
where you can play your favorites in any order. Tap the banner to learn more.
okay, so this is telling us that 11, right, is going to be n n mod 3 is going to be equivalent to, I'm not looking, n mod 3 is going to be equivalent to 2 are all going to be turned on, except if at 4, hang on, 4 n greater than 8 and, right, intersect. Not perfect square. Right, for n mod 3 being equivalent to 2, where n is greater than 8 intersect with perfect square. This is going to be off. Unless said perfect square is also divisible by 8, in which case it will be on. Okay, so n mod 3 equivalent to 2 intersect n, what was it, 8? 8 divides n. That's possible, okay. Eventually. Where n is greater than 8 and intersect with, yes, it's a perfect square. Those will be on. Because technically that also means this one. Greater than 8 intersect with not perfect square. It's going to also be off. I guess. Alright, 8 divides n. Not perfect square. Intersect. Keep the same notation. It's going to generally be on. No, off. Wait. No, they're going to be on. Those are going to be off. Oh, they're perfect square. I don't care. Okay, so 527 is not a perfect square. It is not divisible by 8. And its parity is going to be 51 is 1, 50, yeah, 527, right, should be 2. Not a perfect square, i.e. should be on, in theory, unless I'm missing something else. Ooh, ads. I wasn't looking. Damn. Alright, 2 minutes.
I have a confession.
Righto. So in theory, right, that should fall under this group. So 527 should be on? Question mark? All right. Tonight, we are hashtag not sponsored by Vocation Brewery's Toucan Tropic DDH IPA. Please pour carefully. Oh, good. As opposed to the request on one of these, which was pour vigorously. Like the point was to upend the can so it got as much head on it as possible. It was a some sort of stout. The rules of the lights are different. Oh no, are they like triple switched? Double dry hopped IPA. So, anybody has any experience with those? There you go. This is my pint glass. Zach, you'll probably like this one. The College of Engineering and Physical Sciences at UNH presented the pint glass. Contains -2 to the 4th e to the I pi ounces. Somewhat fruity. Interesting. Follow the considerations given by functions of n. You know, I want to say I saw a number file video on this, which was something else, but it was about, they were doing Venn diagrams, and they were overlapping all the Venn diagrams together, and it was the same sort of thing, where it was, you know, all of the ones that are intersected by, yeah, so, right, so, the ones that are on are going to have an, no, odd parity of f sub k intersections. off, they're going to have an even parity. I mean, what do you mean all functions? All right. We got n squared plus 2. N. 2 of n is, was that 2n plus 8? Right, so then we want whatever's one intersect f2. Right. Yeah, yeah. Oh, that's going to be a pain in the ass if you can allow a function that does that. I mean, maybe not that, or even that. It doesn't matter, because then you could be like, well, it doesn't go negative, so you don't end up with those. Because then you're going to have people who flip on over here, and then they also flip off over there, which would counter what I had said, where it's just the intersections of each of the things, each of the functions. But it's not, because then you have to worry about within each function, what are the intersections. So you have to look for the number of zeros along each, like, along each striation. Well, yeah, but I'm saying, like, if I turn on here and on here and off here and off here, then that is 2 values that are coming in from F1 only. And this is not F1, but F3, right? If I say, okay, this is F3, then I have things that are turning on and off in F3. And especially if we do something else, I don't know, like, you know, make it a 4th degree polynomial and go like that. Then we've got values up here that are going to be changed 3 times. Well, okay. No, okay, 3 times. Right, values up here which are going to change 3 times. So those get turned on. And then when you go a little bit further, there's going to be one that's done twice. And then all the rest of them above that are only once. This was your goal, yeah. That's fair. Right, so we've got to look at the number of solutions for a particular function, for a particular on-off, above 0, and integer valued. Reminded you of on dinner off. Oh, jeez. I mean, that's what we got. That's what we got up here, but still. Oh. Shit, I didn't even look. Are these dimmable? They're like 5 pounds each. It's ridiculous. Yes, dimmable. Good. Also, hashtag not sponsored. McVitie's digestive biscuits. These are like kind of normal wheat cookies, but then have dark chocolate on one side. Usually pretty interesting. Yeah. And then the y values also have to be whole numbers. Although I guess they would be done as an integer sequence. So that would negate the worry about making a function that doesn't work. I mean, you're already there. If anybody's new, good evening and welcome. My name is Obi-Wan Pez. This is N-Simplex Pachinko. We do mathy stuff on Mondays and Wednesdays. We're doing gamey stuff on Fridays and whenever I feel like it. And tonight we're working on some logic puzzles which follow the light switch puzzle framework, although Seth has been giving us differing rules, so alternate rules for this particular puzzle. If anybody does want to have any math answered, feel free and drop that in chat if you have something short or small or easy to explain. If you don't, then we have 2 Discord servers you can check it. That's not what I wanted. Oh my... Alright, stop touching things. We have 2 Discord servers. Penn Center's Discord, and we were just playing with Zach's Discord. So if you go to either of those Discord servers, we have a math forum and math help chat, and you can hop into one of those and drop questions in there if they're something you just want to take a photo of and then drop them in, or what have you. Generally speaking, I have been teaching community college mathematics. That is between like basic algebra all the way through differential equations, usually second year of math major courses, for about the last 15 years. I was teaching at a community college in Maryland and in the United States, and now I'm living in North Yorkshire, England, and having a lovely time just hanging around and trying to make sense of the world. Answer people's questions, have fun, take care of my family, all sorts of cool stuff. Yeah, yeah. Yeah, right. I was counting on that being useful. So I wasn't worried about this particular one, but I was in general worried about like some F3 that does this, just because you could have all sorts of weird stuff going on. Yeah, I know the minimum here is 2. That's easy. Okay, so what is this going to be? This is going to be n squared minus 2n minus 6 is equal to 0. Those are not integers, so we don't have to worry about them. If we want proof, right, 2 plus or minus square root b squared is 4, minus b squared minus 4ac, that's a 30. So yeah. Oh, wait, wow, 28, but still not a perfect square. Doesn't matter. So these two things will not meet at any particular point, and therefore we won't both flip up and down. Yep. So F1, F1 is mutually exclusive. There's a symbol for that. Oh, just, yeah, like their intersection is null. So, this is going to be all F1 union F2, where n is a positive integer, natural number, are going to be on. Oh, but that's not how that works. No, never mind. That's not how that works. Because it doesn't, no, it doesn't, hey Famish. It doesn't matter whether they intersect, literally. It matters whether they hit the same y value somewhere. So it doesn't even matter when they both hit the same value. As long as they both do, then they're going to get, we need the images, right? So like we need the image of F1 intersect with the image of F2. Unless I'm using those words inappropriately. So, yeah, right. and, right? And this is only when n are positive integers, natural numbers. So when are those things going to actually be equal to those? So we have 2n plus 8. So m squared plus 2 equals 2n plus 8. Yay! Never creates a switch turned on by itself due to symmetry and minimum coexisting on function 2. Its minimum is 2 though, and F2 does not go down to 2. F2 starts at 8. I mean, starts at 10, really. Oh, you said negatives count too. Okay, fine, whatever. Okay. If we include n being all integers, then yeah, that makes sense. So F1 is going to be off for all except n equals 0, at which point we get F1 of 0 equals 2, which is going to be on by itself until F2 comes in. All 2n plus 8 for n being any integer will be on except, right, except 2n plus 8 being equal to 2 from here. So again, right, like you said. This is the only one that pairs up with that one. All the rest of them in F1 have been eliminated by themselves. And then in F2, it's a linear function, so we only ever get a straight line. And then there was one number which turned on a switch in all of F1, and we get it paired in F2. So again, it's going to be this. This is 2n is equal to negative 6, so n equals negative 3. Off. So that's going to, come on. That's going to take that out. And then, again, all others. It's not n equals -3. It's the number 2 is going to be off. That was a very simple, very simple example. I'd say we got lucky. Yeah, yeah. Uh. That one works. There's another one that I liked in here. Where is it? Go with that one. That's not it. Still good. Alright, so let's do F1 event is 2 n. That's not what I want. 2n cubed minus 4n squared plus n minus 3. 'Cause why not? Hopefully that's actually interesting. Let's check. Desmos. 2x cubed minus 4n squared x plus x minus 3. Alright, get rid of that. G of x is equal to okay, 5n squared plus 2. Two n. Yeah, I was gonna say. 5n squared plus 2n. Yep, no worries. Alright, so if we get a 1 in there, that is 1 comma 7. And on the other side, we're going to get a negative 1 comma 3. Right. So those are not going to be repeated. Yeah, so... where do these numbers overlap each other? Okay. Right, we want all values that are going to give us integer. We want all values where n is any integer, and naturally they're closed under the integers, so we're always going to get an integer f value, so that's not a problem. But then we care about which f values they actually are. And we would like to know if we ever get the same y value, the same f value out of both functions anywhere. Yeah. So when it equals 0, we get n is equal to, we get 0, and we've got square root of 2/5, so that's gone. And this one, n equals 2.1, so that's never going to be had, so it doesn't matter. So here, 2, negative 1. One, negative 4. Okay, seriously. 0, negative 3. Negative 1. Oh. Negative 1. Negative 10. I guess. Yep. If 1 of n is going to be greater than 0 when we get negative infinity to no. And it's going to be negative infinity to, again, here.
Raiding party!
Uh-oh. Academy of Useless Ideas. Good evening and welcome. Everybody who hasn't been in here before, my name is Obi-Wan Pez. This is N-Simplex Pachinko. We are working on some logical type stuff tonight, and Seth is leading the charge. Yeah, I guess. Bingo. If you have not yet followed Academy of Useless Ideas, there's your link. Go for it. Or I guess you can click on their name and just follow directly from there. So that works. Were you working on any particular problems this evening?
Titles, promotions, and relegations online. The form book can take a back seat, and the drama has the power to rewrite scripts. Get a free £10 bet when you bet 10
Negative 1 with the possibility of negative 1 being used, and then go from 1 to infinity inclusive with all those other bits. Stereographic projections in it and some equalities. Nice. Okay, F2. Oh, that was F2, wasn't it?
Get all the music without hearing audio ads on Spotify Premium. Tap the banner to learn more.
Nope. Boop. Okay, that is 2.1, so therefore we're only going to be using 3 inclusive to infinity. Or are we using room 0? Or are you just saying negative is not used? Hey Slayer, welcome back. Okay. I guess. Come on. Go from... Right, but all of our n's have to still be integers. Yep. Right, so that was negative 2. Negative 2.1. No, positive 2.1 was at 0. So then we can only use from 3 up on that one. That one's okay. Well, come on now, make up your mind. Oh, gotcha. Oop. Oh, there's more in there. Jeez. Okay. Oh, right. And if we're talking about, the multiples of all of the numbers, then clearly, that's not going to work terribly well. Yeah, so everybody coming in from the Academy of Useless Ideas, we've been talking about, such a great name. We've been talking about the light switch problem. So for all n values, person will walk down the hallway and flip every switch for which their number is able to divide into whatever the light switch number is. And then they will go down the hall and keep flipping all of them. And in this very extremely generalized case, Seth has said, what happens if we end up just building any functions for that matter? And saying, yeah, we'll throw in any function and what's going to happen with all of the light switches as we start going down the hallway. In this case, we're just using two functions, but it is infinitely long for this. So the Hilbert Hotel, if you will. Well, okay, yeah. Just what functions are going to hit what values, and then how can we tell when these values are either on or off? So we've already established that if there is a parity of image intersections that is going to be even, then the switch will eventually end up off. If there is a parity of switches that are odd, then the switch will remain on. So the question is, how do we generalize that? Yep. How do we generalize that to this? So at this point, we do have two functions which are continuous, but now we just really want to keep, like, I don't think I can discretize this. No. I mean, I know I can screenshot. My question was, I was wondering if I could discretize the actual values that we're using in there, which I feel like it's possible, but just it's beyond what I understand how to do on Desmos. It's fine. You could definitely do it on... Yeah, you can use a table. You could definitely do it on like a TI. Turn it into a dot version. What is GOtEL? I am so glad that you asked me, Miss Rex. So GOtEL is a charity that we're doing during the month of May called Game On to End Lupus. We're not gaming at the moment, but you know what? It's fine. If anyone is interested in donating, this is a scientific endeavor as well as a human endeavor to try and end the disease of lupus. Lupus is an autoimmune disorder which has, I think it's around 8 million Americans at any given time. Megalomorph? And basically it will attack certain systems within your body, or rather, your own immune system is attacking certain systems within your body, thinking that it's an outside invader when it isn't. There are a few individual antigen inhibitors and things like that, which will help to slow the symptoms or slow the progression of the disease, but it's this is only one of the 3 puzzles, man. But this is a disease which is degenerative, eventually progresses. 8-Bit D, who is one of the leaders of the larger overall campaign, has been dealing with lupus for a long time. It is attacking her nervous system, which also causes her to have seizures and all sorts of issues with her brain, as well as muscular movements. Coco Confession, it's attacking her heart and lungs, so she's having a real hard time just continuing to breathe. And Elbel, with Ellie, it is attacking her motor function, I believe. And she doesn't have an official diagnosis, but, like, pretty sure it's lupus. It's just a matter of getting the formal check boxes. You know, the doctors have to go through a series of tests to make sure that it is actually this thing instead of one of the many other things that it could be. But most likely, given all of the things that she's dealt with, it kind of follows the same pattern as the other two ladies who were there. So Ellie's pretty sure she has lupus. Yeah, I know Megalomorph gets tired a lot, especially now, but yeah, I'm not sure because I haven't talked with him particularly about that. Room movements? Oh. So Seth, I'm not really sure how to particularly, move on with this. Apart from like plugging it in and getting values and then comparing them. Like, how do we do it in general for an infinite set? There's certainly a way to do it, but the question is, like, apart from plugging in ends to F1 and plugging in ends to F2 and then getting all these values, right? So it doesn't, however. We could look for the mapping of what these negative values map to on the positive side and come up with those two functions. So, So, alright, ads are set to start in 5 minutes. So if we go like this, then we say that n is going to be just integers for 5n squared plus 2n union. How do we then make those negatives appear on the positive side? That is just going to be 5n squared minus 2n. Right, so if we mirror this over the x-axis, now we're going to get two functions which are offset from each other ever so slightly. Well, more like that. No, they are actually offset from the center. They're offset down and apart from each other. So that works. I mean 0, 0. Oh, yeah, yeah. I see it now. So if we were to... No, science. There we go. No, that's not what I wanted. You jerks. Why would you do that? That's really mean. Alright. Alright, what is that? Oh, okay. I don't know what I'm doing, it's fine. Okay, that's why. There are separate versions that we can run here. I'm looking at PyCharm, sorry. Alright, ads are going to start in 30 seconds. Not a matter of plugging in, plug into one and solve the other. Okay, we'll be back in 3 minutes. Give me a minute. 18. I don't think I understand what you mean. On, yeah. Yeah, yeah. I don't know what you mean by disregarded though, because like they're there's going to be a lot of them that are on, because I suspect that a lot of these things do not overlap each other, just because they're going to be different functions or different function values. Yeah. Right. I mean, like I said, this is not... I don't think this is going to be useful. Because really what you need to do is plug in a whole bunch of values for each of them and see where they end up coming up. And are they equal to each other? We're going to get a lot of, no, they're not equal to each other. This is a unique value, so therefore the light is going to be on for those values. And I don't see a nice way that we're going to be able to just solve for whatever. I'm not seeing a nice way to do this. Not really. I mean, programming is very nice, but generally speaking, I'm not seeing like just a way to say it's always going to be these particular values. Apart from, it's the values that are in these functions. Right, so... is it possible that a 5n squared plus 2n... You know what, just 5m squared plus 2m is going to be equal to 5n squared minus 2n. Right, so if you can answer that question easily, then we... Nope. Then we might be able to come up with something useful. So, in this, I'm seeing like 5 times m squared minus n squared, some integer value, plus 2m minus n, which is going to be 5 equals 0. Right, so 5m plus n m minus n. Right, this is going to be obvious. N. Right, one of these answers is obvious. M minus n equals 0. Therefore, m equals n. Right? Obviously. We're just going to skip that. The other one is that when 5 times m plus n is equal to negative 2. So here, m plus n is an integer, but this is going to be 5k, right? Some other integer is going to be equal to negative 2. So that's never going to happen. Right, so the sum, or you could do it like you did it. The sum of two integers is going to be equal to negative 2/5. Well, that's never going to happen, so skip it. Right, knock that one out. Right, so in this case, right, these values, and realistically we knew that because again, this is two parts of a parabola, which is offset, and we just flip this one around to be in the opposite direction. Here, we're never going to actually hit the exact same values for any two integer values, m and n. Because when we do this, right, we're picking asymmetric values. We're picking asymmetric values. But this set up a framework to be able to do the other thing. So, will 2m cubed minus 4m squared plus m minus 3 ever be equal to 5n squared plus 2n, or 2m cubed minus 4m squared plus m minus 3 be equal to 5n squared minus 2n. So, in theory, we might be able to do something with this also. I don't really like it, but nonetheless, it'll maybe work. 2m cubed minus 3 is equal to, move that other stuff to the other side. This is 5n squared plus 4m squared. I don't like it. Plus 2n minus m. Right. So like this is not helping. Can we factor? Lol. Maybe. Right, so 2m cubed minus 4m squared minus 5n squared plus m minus 2n minus 3 equals 0. So, like, not really, right? Because you don't have like terms. We're not going to be able to combine stuff, really. Right, we can't really combine anything here, because we don't know. Pull a 4 out for minimal merit. Without any cross terms, obviously we're not going to get any like m plus n binomials, right? This is all just going to be kind of a big mess. in theory, could we transfer a... You know what? Hell, let's try it. I don't think this is going to do anything. 2m cubed minus 4m squared. Notice that these are off by a factor of 2. Plus m minus 2 equals 5n squared plus 2n plus 1. So we transfer 1 from one side to the other. Sure, why not? We can do a set of grouping on the left. This is going to be 2m squared. Leaving behind an m minus 2 plus 1 times m minus 2 is equal to, can we even factor this at all? That's 6 with a different, or with a sum of 2, so no, not factorable. 2m squared plus 1 times m minus 2 is equal to 5n squared plus 2n plus 1. Sure. Why not? Yeah, but I mean, we're not even looking for factorable, right? Because you're not going to get a 0. We don't care about the zeros. We care about when it's equal to the other side. So like, we've got, oh, wait a minute. Hang on. Wait. So, this means that like our constant factor from the other side with the n's, it could include n and n squared, so never mind. I was thinking like maybe this is just a different, the stuff on the left could be a factor pair of also the stuff on the right, but since it doesn't have a nice factor pair on the right, then we might be able to say that the only factors that we get over there are irrational, and we can get a rational factor pair on the left, so they're incommensurate with each other, and therefore it doesn't work. I don't know how valid that is. No. Because we just get a -2, but the 1 from the -3 can shift to the other side as well, and we get here the factors of 5 and 1, which add up to -2 instead of +2, but you're going to have the same problem either way, right? The only factors of 5 are going to be 5 and 1, and the only way they can add up to having the same values is if you do 5 plus 1, which is 6. So that's it. So we'd always have to get 6n in the middle. If it was a -1, then we'd have to get a 5 minus 1, which is going to be a 4 or -4 in the middle. It is theoretically possible that all lights would be on. I wouldn't want to bet my life on it, but like, I don't know, 20 bucks? Bet some subs. No, don't do that. Right, so let's just friggin' pop up one of these. Let's pop up one of these sheet things. And then make a new sheet. So do like n, just for fun. Copy. I have no idea if this is going to work. Paste. Yeah, I did that. I hit control. I hit control V. Are you kidding me? God. Okay, get rid of the LaTeX because we don't need it. That's not the thing, is it? No, that is. Okay, never mind. We're good. This is 5x squared minus 2x. And whatever, it's fine. Replace. Nope, that's not what I want. Find. Expand? Yeah. Replace. Find x, replace with n. Replace all. Done. There we go. Okay, so 1 equals that plus 1. Yes, please. Alright, so equals that. But in this case, what I want you to do is take this number and instead use that number over there, A2. Take A2, cube it. Good. Ah, wait. 2 times. Minus 4 times, delete, parentheses, A2. Squared. Plus A2. Minus 3. Control Enter to autofill. Sure. Okay. So we're also going to do the same thing here. It's going to be equal to yeah, it's fine. I could just retype everything. A1 5 times A1 raised to the second power? Oh, 2. A2 raised to the second power. Cool. Plus 2 times A2. Yep, Control Enter. Right, 5 times A2 raised to the second power minus 2 times A2. Control Enter. Cool. Right. So we say, okay, these here and here can't be used. So delete. All right, start with 3. Right, so then here we can do some conditional formatting. Conditional formatting. Color. Is equal to any other. No? No? Alright. That doesn't really work. No. I just wanted to check values against each other, but it's not going to do it. That's too bad. Is the same as. Right, yep. Because... Right, so this one and that one should be eliminated, but... No. See, this is the thing, is that we already counted these two here. These are the mirror images of the parabola, right? It was that this was taken over here. So now we've got two going like that. So we don't need negative n because we used the, use the equivalent. Yeah, and we already said that there's never going to be a repeat anywhere in those two. So it's just comparing it to this stuff. Right? And then we just have to look over and be like, nah. Right? 494 is not here. 773 is not here. 1140 is not there. I don't think we're really... This is probably not a good expenditure of time. I think we can pretty well be convinced that there's nothing here that we can see. So, up to 6,500, up to there. 5862 is not there. 4715 is not here. 3700 is not there. 2889 not there. 2186 not there either. 1607 not there. 1140 not there. Yeah. Oi! Oh, never mind. What happened? Oh, Ko-Fi's not working. I guess we've never had to worry about that anyways. Oi. Okay, so we'll just turn that off. It's fine. Yeah. So like we okay, we can just keep going down. And 225 sounds like a good number. Fill down. Right? These are expanding quadratically, and that's going to be a lot of numbers. And we've got to check, like, these numbers here to those numbers there, and so on and so forth. So it's going to be, like, these are going to become more and more disparate as we go. There's not really any way that I know immediately that we could just immediately check whether these numbers in this column are going to be repeated anywhere in either of these columns. In theory, you could line them up to say, like, I only want you to check the things that are of the same number of decimal places. So, like, is the log of one floored equal to the log of the other floored? And if so, check. There's not code in spreadsheet. Yeah, I'm not surprised. That's ridiculous to expect that it would do that. But I mean, you could also do that in Python, right? And just get it to check for you a limited set of results. Say, like, are we going to look for repeats within a certain number of locations? So obviously, I do not want to check literally the entire spreadsheet or the entire column of data. I do not want to check the entire column in order to figure out if 40,793 is going to be repeated in either of these columns. I probably, like I said, would probably only say pare it down so that the log of that particular number is the same, then check. That might be just doing an extra operation that's not necessary. Yep. Because that's two operations. I don't know, what's faster? Is doing log base 10 and comparing to a number going to be easier than comparing a quality to a number? I'm thinking like big O notation. Are we... You go down the list and you find like the first place where it hits that same number of decimal places. And then you go down and you find the first number that's greater than the number you're looking for. And then you just say no and stop. Right, because these are monotonically increasing. Right, because they're monotonically increasing, you don't have to worry about like missing something. As soon as we hit 40,000, 40,680 is smaller than 40,793. So we go one further to 41,587. That's greater than the other number, and so you just say no. We're not going to search any other numbers below that. I don't know how you would search. Say like we're not searching any numbers above that particular value, or like I said, you know, the same number of decimal places. So is there a way to easily say, look, we're looking for a 5-digit number. A priori, right? Before we actually even search, before we even plug it in, right? Can we figure out what's going to be a 5-digit number? The answer there, I think, is no. Actually, we do know that we're multiplying by 2, or sorry, we're squaring the number, and we're multiplying it by 5. So there is the possibility of doubling the number of zeros that we have and adding 1. And then over here, twice that number, we have the possibility of likely staying within the same, but adding 1. We could potentially add 1 0. So here, if we want 5, right, this could be 2n plus 1 plus 1. So 2n plus 2, we want 5 zeros. Maybe you could get something from... Yeah, maybe you could get something from a one-digit number. It's not likely. From two-digit numbers... Right, so if we did like 100 times 2 is going to be 10,000, times 5 is going to be 50,000, plus, what did I say? 100. So 50,100. So we're not, no, we're not adding zeros from this number here, right? Because we just doubled the number of zeros that were there. So we're already to the point where we can look at it in terms of, you know, what's the highest integer value that we're... It's not what I wanted to say. We're already looking at what's the first term doing and ignoring all the rest of it, provided that your coefficient is not ridiculously large. So, we're taking the location that we're at, we're doubling the number of zeros, or decimal places, that number has. So from 2 to 4, multiplying by 5 could add 1. That is the most that it could do, asterisk. It's helpful, thank you. You know, I've seen that one before. I've used that one before, but just equals COUNTIF a to a, comma a1 greater than 1. I don't want to include column A. So E to D. Comma. No, not comma. Yes, comma. Okay, this is looking for single values. E2 to D. Okay, just all. Yeah, that'll work. And greater than 1. Expected 2 arguments got 1. Okay. COUNTIF. Range criterion. Right, yeah, it's listed literally right there. Ugh. Okay, hang on. Yeah, but I want them to be equal to each other, so like... That's going to be rough. Can check. Okay. Unique. Count unique. That could also work. I don't care about the friggin'... Alright, syntax. Count unique, value 1, etc. Oh, takes a maximum of 30 arguments. That's bullshit. Well, actually, right? $670. Okay. Count. Right? This is B2 to D. There we go. We just want to know if those numbers are equal. So they are. Yeah. Do 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 do. 700. 800. We'll go to 1,000. 900. 1,000 and oh yeah, that's the end anyway. 999. Oh. 2,995. Bam. So those appear to be unique entirely all the way through. Man, just add a row. Boop. It'd be really funny if there was just that one. But realistically, right, we don't know if it is the next one literally forever. Like, we could just keep going and add one more row and add one more row and add one more row forever. But yeah, realistically, I don't think we're gonna come up with one, right? I think these are probably unique. Obviously, again, the second two are going to be unique. Columns C and D have to be, because they're effectively parallel to each other, and they're only offset by an irrational... no. I think they're offset horizontally by an irrational amount. So if we were to go with 5x squared minus 2x, right? That's not irrational. Okay, it's rational. It's horizontally offset by 2/5. But the fact is that if we try to go to any particular value and like put both of those in, we're going to get 1,7, and then 1,7 is going to correspond with 1 comma or 1.4 comma 7. So those values can never match each other because they're going to be non-integer differences. Right, horizontally, non-integer differences. Then the only way to make this work is to have this one over there, our red one, be either of those numbers. Well, be that same value at the exact same crossing, either here or here. So we could have 1, 3, or we could have 1, 7. They're offset vertically by 4, so we have like 2 chances in order to hit this cubic. Like we said, out to 1,000, it's not going to happen. So I don't think we're going to end up with it. So we can't necessarily guarantee that in an infinite case. However, right, wait, hang on. Wait. They have to be horizontally offset by an integer. Okay. This is going to be insane. Is F that, right? None of that's going to work. Is 2n cubed minus 4n squared plus n minus 3 equal to 5n minus c squared plus 2n minus c. Unlikely to be able to solve this, but you know what? Let's just try something. Just 'cause. 4n squared. This is obviously the easier way to do this, because you could make n minus c the cubic, but ew. Alright, so then here we're going to get 5n squared minus 10nc plus c squared plus 2n minus 2c. Move the stuff that's common. It's going to be 2n cubed minus 9n squared. 2n is going to be minus n and minus 3. There's no common there. Equals negative 10nc minus 2c plus c squared. I don't think this is going to be helpful. N minus c is the n value on the other side, the same n value, but shifted some c value. So this constant has to be c, the shift value, which must be an integer. So as long as n and c have to be integers, can we do this? Alright, that's gonna be gross. Eh. Yeah, I mean, realistically. So it'll be like a negative 5c times 2n plus... Oh, what did I do? No, that's supposed to be a 2. Negative 2c 5n plus 1 c squared. Or, right, I suppose we could bring it to the other side. N times 1 minus 10c plus 3 equals negative 2. Okay, c squared plus 2c. we went this way, this is going to be... Yeah, these still combine N's and C's, and it's a little awkward. Not liking that too much, but it's an option. This one at least gets it most of the way out. Gross. Yeah. About that. Because it's coupled with the N, that makes it a lot harder. Okay. If all these things are integers, then the right-hand side is going to be an integer. The left-hand side must also be an integer. That's not a problem. Never mind. Whatever. Let's just try it. Okay. You know what? Let's even go back here. F of x is going to then be equal to that stuff. G of x minus c. Add a slider for c. Then c must also be integers. Step 1. Oops. It's not helpful. Right, so like this is definitely crossing at some point here. But that's really ugly. So we go to like -1 and it'll cross somewhere up here. Which is also really ugly. And then we just keep doing that. Okay. In theory, could also go back to the spreadsheet and try. Right, so no, wait, hang on. Our ends are already shifted. Right? We could shift it by 142, and then we end up with these numbers all the way back up there. So we've effectively already shifted it. Right? Because it's got to be integers. Yeah, so never mind. We've already done it. We're good. Alright. Well, problem solved. Slightly roundabout way, but it's alright. Awesome. Alright. We're going to go see who is available here. Yeah, I mean, technically we haven't proven the infinite case. But, like... We've now proven that you can't shift a particular function until it's back within the range of 1,000. So that's not going to happen. Either positive or negative. Because we also reflected the one function so that going 0 to 1,000 was the same as doing 0 to negative 1,000. So yeah, none of that's working. Yeah, none of it's working for within negative 1,000 to 1,000. Yeah, so it seems likely that this is going to be able to go off to infinity and never actually have a repetition. But at the very least, we've got, again, negative 1,000 to 1,000, no repetitions. So, seems reasonable. Okay, Dr. Gold's on, so we'll hop over to his stream. He's doing standard... Yep, standard exam type questions, so we'll head over there. I will see you all at the very least on Friday for some gamey type stuff. Again, probably Oblivion. We'll see how that goes. And other than that, we will possibly be back for some more random gaming either tomorrow and or Saturday. We'll see how I'm feeling. We'll see how the stream's going. I do need to do some Elite Dangerous stuff to try and capture a system. I'm like pretty close, so it's not really capturing, it's just, you know, being an architect and building. So we'll see you all later. My name's Obi-Wan Pez. This is Simplex Pachinko. Thanks so much for everybody for helping out, coming in, hanging around, and Seth for problems. Alright, see y'all later.